Hey, hello class. Welcome back to the STL sessions. In the last sessions, I briefly introduced you the standard template library. I said that there are 4 key components in this STL: the container, iterator, adapters, and algorithms. In these sessions, I will talk about the iterator components in STL. So let's begin. Iterator is a generalized of a pointer which can be used to access elements stored in containers. Iterator is not a pointer, but you can use it just like pointer because increment, decrement, and dereference operators are overloaded in iterator. Iterators are designed to hide details of the implementations, and they are give consistent interface across different container classes. So you can say that iterators are abstracted because detailed implementation is hidden to user, and because it provides consistent interface, you can access element using similar syntax across different containers. And each container classes has its own iterator type. But because iterator provides consistent interface, like I said before, you can use similar syntax to access element stored in the container classes using the iterator. Iterator is not a pointer, but it is okay for you to think of it, think of iterator as it is pointer. This is because iterator overloaded operators shown here. The increment, decrement, equality, and the referencing operator. So you can use iterator just like using a pointer. So all these operators we use for the pointer. So just like a pointer, you can use these operators in iterator components as well. So vector that we learned in the previous sessions is container class in STL. Vector classes iterator have overloaded all these operators. And vector class also has member function begin and end, shown here, begin and end. These begin functions returns iterator that points to the first elements in the containers. And the end member function returns kind of end marker that indicates the end of the elements, very similar to null. If you look at this example, this begin functions returns an iterator for the container C that points to the first elements in the container C. End function returns end marker, which indicates the end of the elements. So this is the iterator type. IT is the name identifier of the iterator. This is the iterator type. Note that each container classes in the STL has its own iterator type. Since we are dealing with vector in this example, the type of the iterator looks like this. You specify the namespace std because vector is defined in standard this std namespace. And you specify vector and put the base type within angle brackets and specify the iterator using scope resolution operators, indicating that this is a iterator type for vector of int. So this is how you declare the iterator variable. And using this begin member function, you can obtain the iterator of this C container. This example code shows the common way to cycle through all the elements in the container class using iterator. Note that we use auto here, and we use begin member functions, and we use end member functions to traverse all the elements stored in the container class C. And P here is the iterator, because this begin function returns iterator, which points to the first element stored in the container. And we are manipulating P using P just like a pointer using dereference operators. And we also use increment operator to access the next element stored in the container. So even though P is not a pointer, is an iterator, you can just use P as pointer. So this is the typical way we use iterate components to traverse all the elements stored in the container. Here C is a container. Let's look at this vector cycling example coding terminal. Vector cycle. So this is the example code. Let me first compile this program and see the output. Vector cycle. Okay, so this is the output of this program. Let's look at this program. Here we declare the vector container, and we specify int as a base type. So this vector container should stores the value of type int. And in order to use a vector, you have to include the vector library, and you also have to specify this namespace. Here we are storing 4 values into this vector container, 1, 2, 4. And here is what is in the container. So here we are printing the element stored in this container, which is a vector, using the iterator. So we first declare the iterator for vector class. So we learned that we first specify vector and specify the base type and write the iterator using scope resolutions. So this is how you declare the iterator for vector class. So P is our identifier. And using begin functions, we obtain the iterator, which points to the first element stored in this vector. And that iterator is stored in this to this P. And we iterate starting from this first element to the end and increase by 1. And we can access the elements by using the reference operator, just like a pointer. So 1, 2, 3, 4 print in this line. So after that, it prints the setting entry to 0, which is mapped to here. Here we also iterate. We also iterate the all the elements stored in this container using an iterator, and set the value of all the elements to 0. So using a dereference operator, you can also update the value of the elements, not just receiving the values. You can also update the value as well. And after this iterations, this program prints this one. Container now contains maps to the maps to this, and we are again iterating the elements stored in the vector container, and prints the value of each element stored in the container. And this time, all the elements stored in these vectors are 0 because we set 0 here. So this is how you use an iterator to traverse all the elements stored in the containers. And this shows how you can access the elements using a dereference operators. And this is how you leverage begin and end member functions. Okay, so let's go back to the slides. We learned that this is the iterator type for vector of int. Also note that each container has its own iterator types. So list, deque, set, map, they are all containers, and therefore they all have their own iterator types. So this iterator is for the vector class. The other container have a different type of iterators. But because iterator provides consistent interface, even though each container has its own interface, its own iterator types, they are all used in similar ways. For example, here the iterator type for list container is shown here, very similar to the vector of int container. Only difference part is this one, list and vector. So this is the power of consistent interface. We will look at the advantage of consistent interface using a demo code in later slides. There are different kinds of iterators. The iterators are classified as shown here: the forward, bidirectional iterators, and random access iterator. They are classified according to the operations that work on the iterator. The forward iterator only works on increment operator. The bidirectional iterator works with both increment and decrement operators. The decrement operator is similar to increment operator, but it moves the iterator in opposite directions. So that is the reason why it is called bidirectional iterator. The random access iterator works on not only increment and decrement operator, but also it works on the random access operations as well. The random access means that we can go directly to any particular elements in one step. So you don't have to traverse all the elements to access a particular element. Using a random access, you can access a specific elements in one step. So what this means is that these below 3 lines are the examples of random access. These 3 lines uses a different notation, but they do same things. The first 2 uses square bracket notations, like accessing elements in array. The last one is analog to pointer arithmetics. They all access the third element stored in the container. And they are random access because we are directly accessing the third elements in one step. We are not traversing each element stored in the container. So that is the random access. Let's look at this demo code in the terminal. So let me first compile this program. So this is the output of this program. So let's look at this demo code. Here again, we are using a vector container. This time, the base type is char. And here we are adding 4 elements to this vector container, A, B, C, D. And after that, we are printing all the elements stored in this container. So this line maps to here. So as you can see, A, B, C, D's are properly stored into this vector. And after that, we obtain the iterator for this vector class using big member functions. So these functions will return iterator, which points to the first element stored in this container. And here we are using a random access. Using a random access to obtain the value of the third element stored in this container. So we are using a square bracket notations. So we can use square bracket notations with container objects and also with the iterator. P is an iterator shown here. So this is a random access iterator. P is a random access iterator. And we can also use an iterator like pointer arithmetic expressions. So this line maps to here. As you can see here, all these 3 lines print C, which is a third element in this container. So this 3 line works correctly. And P container begins. So now this P iterators goes back to the first. This P iterator now points to the first element stored in this container, which has a value P, So this maps to here. It prints A because the first element is A. And 2 steps forward and 1 step back. So after printing A, it uses an increment operator to go to access the next element. So second element is B, so it prints B, and it uses the increment operator again to access the next element. So the next element is C, so it prints C, and now it's using a decrement operator to access the elements, to access the previous elements, which is B here, because previous element of C is B, so it prints B here. So this example code shows you how to use a random access iterator using a square bracket notation directly with container as well as the iterators. And you can also, the iterator can also be used as a pointer arithmetic expressions. And using this increment and decrement operators with this dereferencing operator, you can access the elements stored in the containers. And P here is an iterator. And again, we are using begin member functions to obtain the iterator that points to the first element stored in this container. Okay, so let's go back to the slides. We saw this demo code in terminal. So we learned that there are 3 different kinds of iterator: forward iterator, bidirectional iterator, and random access iterator. But we can further categorize the iterators into 2 different categories. So for forward iterator, bidirectional iterator, and random access iterator, it can be divided into constant and mutable iterators. If the dereferencing operator returns a read-only versions of the elements, then they are constant iterator. So because it is read-only, you cannot change the value of the element using the dereferencing operators. So this one is illegal for the constant iterator. You cannot update the element values using this dereferencing operator. On the other hand, with the mutable iterator, you can update the element using the dereferencing operator. So if the iterator is mutable, you can update the element using this dereferencing operator. So that is the difference between constants and mutable iterator. In some situations, you might want to cycle elements in reverse order. You might think you can cycle elements in reverse order using this for loop, starting from end until this P is begin and uses these decrement operators. This for loop looks okay, and this code may work in some system, but this code is wrong. I mentioned that the end member functions returns the end marker of the elements. So one more time, this end member functions returns the end marker of the elements. So this is the difference to the last element stored in the container. So this end member function returns a iterator that is not located at a data items, but that is a kind of end markers. So this is not a correct way of cycling elements in reverse order, because this one is not pointing to the actual element data. Instead, you have to use reverse iterator shown here. Reverse iterator is only provided with container with bidirectional iterator. The type of the reverse iterator is shown here. Very similar to the type of iterator, but you put the reverse here. And instead of using begin and end member function, you use R begin and R end member functions. R stands for the reverse. The R begin member function returns the iterator that pointing to the last elements stored in this container. Using for loop like this, you can cycle elements in reverse order, and note that we are using increment operator, not decrement. So let's look at the demo code for the reverse iterator. Reverse iterator is here. Okay, so let me compile this code as well. Okay, we are using a range-based for loop, so okay, so this is the output of this program. Again, we are using a vector, just like our previous example code. Base type is character, and we are adding 4 elements to this vector container A, B, C, D. First of all, we are using a iterator to print the elements stored in this vector. We use a begin member function and end member functions, and IT is a iterator. So as expected, the program prints A, B, C, D because we stored A, B, C, D here. Now we are printing the vector in reverse order. So the correct way of doing that is using this reverse iterator. So this is the type of the reverse iterator. And instead of using a begin member function, we use R begin member functions. So this returns the iterator, which pointing to the last element stored in this container. And we also use a R end member function, not just end member function. So don't make mistake. You have to use a R for reverse ordering, and we use an increment operator, and we print here. So This time it prints the elements in reverse order, D, C, B, A. So this is how you iterate elements in reverse order. Let me comment out this one, look at this one. So you might think this loop also prints the elements stored in the container in reverse order because it starts from the end till begins and decrement each time. So you might think this one also prints the elements in reverse order, but if we compile this program, it compiles well, but if you run this program, the result is not expected. DCB, not A is printed and there is space here, very strange. So this loop does not work properly, so don't use this way when you want to print the elements in reverse order. This is not correct because this AND member function does not return iterator that pointing to the element data. It just returns the iterator which indicates the end of the elements and marker such as a NUR. So that is the reason why this loop does not expect it. This loop behave abnormally, so don't use it. You have to use a reverse iterator. And one more thing, this is the type of reverse iterator, but this is very verbose, very long. What we commonly do when we are using an iterator, we use an auto. So instead of specifying this verbose type, you can just write auto here. So this one should also work as well. Good, it works as expected. So what do you think? Which one is better, the first one or second one? The second one is better because it's simple. The first one looks very verbose and complex. So that is the reason why we commonly use auto when we are using our iterator components. That's one tip. Okay, so that's it for the iterator components. And that's it for these sessions. In the following sessions, I will talk about the container components in STL. So see you in the following sessions.